All right, welcome. This is a masterclass briefing, and we're jumping right in. We're here to give you an advanced framework for diagnosing and, just as importantly, justifying compressed air system efficiency projects. Let's get straight to the engineering and the numbers. So, first things first, let's talk money. You have to understand the financial stakes. Look at this. Over a compressor's 10-year life, the purchase price is practically a rounding error. Energy, at a massive 82%, completely dominates the total cost of ownership. This makes efficiency the single most critical operational objective you can have. Now, here's the crazy part. Even with that massive energy bill, the typical system is just incredibly inefficient. We're talking only 5 to 15% of the electricity you pay for actually becomes useful work. The rest? Gone. Wasted as heat. And you know what? That huge gap, that's our opportunity. Okay, here's our roadmap. We're going to follow the exact path of a real-world energy audit. We'll start by figuring out the real cost. Then we'll diagnose the waste, build a game plan, arm ourselves with the math, and finally, build the case to justify the investment. So let's kick things off with Section 1. We need to nail down the true cost of air. And this is all about understanding the huge energy conversion penalty that's built into every single compressed air system. It's a factor that honestly gets overlooked way too often. And this, right here, illustrates the core problem perfectly. To get just 1 kilowatt of work out of an air motor, you need to pump in 7 to 8 kilowatts of electricity. I mean, look at the annual cost difference compared to an electric motor. It's night and day. This conversion penalty is precisely why using compressed air for the wrong job is so financially destructive. Okay, so we've established the cost. Now we need a structured, systematic way to hunt down the primary sources of waste. You know, a successful audit isn't about luck. It's about knowing exactly where to point your flashlight. And here they are. Think of these as the 4 horsemen of compressed air inefficiency: leaks, inappropriate use, artificial demand, and bad controls. These are the key areas you have to investigate, and I mean really investigate. Each one is a huge opportunity for savings. And what's worse, they usually feed off of each other, making the whole problem bigger. Now, let's be clear about leaks. This is not some minor maintenance task you get to when you have time. It is a massive, constant drain on your capacity and your energy budget. We're talking 20 to 30% of your compressor's entire output, just gone. Think about it this way. It's like leaving a machine running 24/7, 365 days a year, producing absolutely nothing. So beyond the obvious leaks, we have this absolutely critical concept called artificial demand. Basically, by cranking up the system pressure higher than what's actually needed, you force every single unregulated application, and yes, that includes every single leak, to use way more air than it needs to. It's a totally self-inflicted wound on your system's efficiency. All right, we've diagnosed the problems. Now it's time to build our playbook. And this isn't about patching things up here and there. This is about deploying a full set of strategic, high-impact interventions to optimize the entire system, from end to end. And this list right here, this isn't just a checklist, okay? This is a coordinated, systems-level attack plan. We're hitting both the supply side, with things like advanced controls and heat recovery, and the demand side by hunting down leaks, dialing back the pressure, and optimizing our end uses. The real magic, the real impact, happens when you tackle all of these together. And just consider this for a second. It's a staggering figure. Up to 93% of the electrical energy you're paying for to run a compressor, it just turns into heat. But here's the twist. That heat isn't just waste. It's a resource. You can recover up to 90% of it and use it for other processes, like heating water or buildings. You can literally turn one of your biggest expenses into a valuable asset. Okay, now we're getting to the absolute core of our toolkit. In this section, we're diving into the essential, non-negotiable formulas you need to go from just observing a problem to actually quantifying it. This is how you build an irrefutable business case. First up, you have to establish your baseline. You have to know what you're actually consuming. Using voltage, amperage, and power factor, this standard formula calculates the real power draw of your compressor motors in kilowatts. Look, without this accurate baseline measurement, any savings calculation you do is just a guess. It's pure speculation. So, we all agree leaks are the #1 source of waste, right? Well, this is the formula that lets us quantify that waste. By measuring the pressure drop over a set amount of time in an isolated system, we can calculate the exact leak rate in liters per minute. This takes it out of the realm of we have some leaks and gives us a hard physical number to work with. Now, this formula, this is the critical link. This is the one that speaks the language of business. It translates that physical leak rate we just calculated into a direct annual cost. You multiply the leak rate by your system's specific power, the operating hours, and your energy cost, and boom, you have the dollar figure that gets management to sit up and pay attention. Okay, now shifting gears a bit. For dynamic compressors, like centrifugals, you absolutely have to understand the affinity laws. It's a total game changer for your control strategy. The first law is simple. It's linear. Flow is directly proportional to speed. You slow the compressor down 10%, you get 10% less flow. Simple as that. But then the second law builds on this, and the relationship gets a lot more dramatic. Pressure changes with the square of the speed. So that same 10% speed reduction we just talked about, it doesn't drop the pressure by 10%. No, it drops it by about 19%. You can see how the effect starts to compound. And this right here, this is where the mind-blowing savings are. The cube law. Power is proportional to the cube of the speed. This exponential relationship is the magic behind why variable speed drives, or VSDs, are so incredibly effective. Think about it. A small 20% reduction in speed doesn't just cut energy used by 20%, it absolutely slashes it by nearly 50%. This is, without a doubt, the most powerful law in our entire toolkit. And finally, we have this simple payback formula. This is what ties it all together. It takes all of our complex engineering analysis and translates it into the one single financial metric that every executive understands. How fast will this project pay for itself? So for our final section, let's talk about packaging all of these findings. We're going to turn our technical analysis into a strategic recommendation that not only makes sense, but actually gets that executive buy-in. And look, this perfectly illustrates the potential we're talking about. These aren't theoretical numbers pulled from a textbook. These are the actual documented savings from Ford's Woodhaven plant. A targeted 18% cut in their compressed air consumption resulted in saving almost 8 million kilowatt hours and over $360,000 annually. That's the scale of the prize we are chasing. You know, the smartest way forward usually isn't some massive company-wide overhaul right out of the gate. It's a targeted pilot program. Find one facility with high consumption, apply this entire toolkit, measure the results meticulously, and then use that proven success story as an undeniable business case to scale the program across the entire organization. So we're going to end with a direct challenge to you. Take these tools, take these strategies, and yes, take these equations. Apply them to your single biggest opportunity for impact. Quantify the savings and calculate that payback period, because that number isn't just an answer to a math problem. It's the key that's going to unlock the investment and start turning all that wasted energy into pure bottom line profit.